Okay. So are there any questions on this example? Now we have another one. Okay. So here's our third example, right? 5x cubed minus x squared plus 2x plus 7. We're dividing it by x plus 2. Okay, that's our third example. Remember, we want to write this, the divisor, as x minus something. I mean, I didn't write it here. Let me write it actually. The pen. So this is equal to x, right, minus 2. You always want it to be x minus. No big deal, because you can write plus as minus a negative. That's why we have minus 2 here. Now, these coefficients of f we put here. 5 minus 1, 2, 7. And it's just like before, right? The coefficient, the first one, you just bring directly down. Multiply, negative 2 times 5, that's negative 10. Added to negative 1, we get negative 11. Negative 2 times negative 11 is 22, right? Sap and Sun rules, that's why. This is addition. This becomes plus 2 and 22, 24. So we're adding minus 2 and 24, minus 48. Now we add 7 to minus 48, get minus 41, right? We're adding. So the coefficients, these numbers, these are the coefficients of the quotient. It's always 1 degree less. So this was degree 3, this is degree 2. 5x squared minus 11x plus 24. This is our remainder. So we have altogether f of x is x plus 2 times this minus our remainder. Excuse me, plus in this case the remainder, which is minus 41. I wrote this as minus 41. If you wrote it as plus minus 41, that's okay. Same thing. Awesome. Okay, any questions on this? I mean, after class, I'll email you guys the full set of notes. I know the notes I sent you doesn't have the solutions in it. I wanted everyone to try this. Like on paper, like, you can write it down. Obviously, you don't have to hand it in, so. Okay. So for the next one's here, the next one here, I was going to have you guys try these two out as well. So what happens here is you have a polynomial, f of x, a polynomial function actually. Here we have a root, minus 3. Then what I want you to do is to divide by, once you confirm, you can confirm it's a root, I did that, but you can divide by x minus the number and then divide. I'm wondering, it might be good. Let's do the first one together because it's probably a little confusing. So what I'm asking you to do, let's do the first one together. 2, I'll let you guys do. So for 1, okay, this is 1. So this is our polynomial. Normally you don't have to do this unless I ask you to. I just confirmed it's a root. Remember, what I'm using is the so-called factor theorem. That is, in other words, I'm just plugging in negative 3 into our function, into our polynomial, and I'm getting 0. Well, that's how we know minus 3 is a root. But that also tells us, remember, by the factor theorem, x minus negative 3 which is x plus 3, right? That also tells us that x minus 3, right? That's a factor of our dividend, f of x. That's a factor of it. In other words, when you do synthetic division with x minus negative 3, you should get a remainder of 0. That's what I'm doing here. We have minus 3. Again, this is plus 3. I wrote it as x plus 3, but you want it as x minus negative. So we have minus 3 here. What I have is right. It's just I didn't have this step initially. 2 we bring down, right? These are the coefficients, as you can see. Between the leading term and the last term, again, you want to make sure it's written in standard form. The leading term is this, 2x cubed. And the last term is the x term, okay? So we have 2, 16, 30. Same process. The 2 comes down, okay? Then we have minus 3 times 2 is minus 6. 16 plus negative 6 is 10. Negative 3 times 10 is negative 30. And 30 plus negative 30 is 0. So we do get a remainder of 0, right? Remember, from the remainder theorem, this is also the remainder. So since this is 0, right, we just in a sense confirm that this is the remainder. When I was actually going through this, I made a few mistakes, and I wasn't getting 0 as my remainder, but I knew I was supposed to because of the remainder theorem and the factor theorem that this is a factor. So the remainder should be 0. So I fixed my mistakes and we're good. So now we know the quotient. The quotient, right, it's degree 2, it's 1 less. 2x squared plus 10x. Our remainder is 0. So we have this. Right? Normally you would have plus the remainder. The remainder is 0, so we don't have to write plus 0. Notice though, I'm factoring the quotient. In other words, I'm factoring our polynomial completely. That's why we like to do synthetic division, polynomial division in general. So we have this. Right? Here you can see that the GCF, the greatest common monomial factor, is 2x. Right? 2 is a factor of 10. The smallest power of x is just x to the first. We have 2x. We have 2x. 2x squared over 2x is just x. 10x over 2x is 5. So we get this. Now this was the quotient. So if I put this back in, we get this. And the 2x I just put in front. So now this is what I want you to do with the second one. Basically, you don't have to check that 5 over 2 is a factor, but you are going to do synthetic division with x minus 5 over 2, number 2. Okay, so that's really what I want you to do. I mean, what you get out of that, you should be able to factor further. We'll do that together, though. Again, just make sure that you do synthetic division here. So I'll give you guys about 5 minutes. And also, after class today, I'll email you guys a full set of notes. Okay?